So what we're doing now is, this is lesson 14, I think day 4, I want to say. So we got through the sine, cosine, and tangents. We got through plotting, polar, rectangular, and now we're going to talk about coordinate conversion. I'm going to go from rectangular to polar today. Tomorrow we'll do polar to rectangular. That means we'll review on Wednesday, quiz on Thursday. That's the plan. So let's continue to rectangular to polar in conversion. Now the first thing you're going to want to do is plot the rectangular coordinates. That's the i's and j hats. Plot that, and after you've plotted your point, we are going to draw a right triangle. It's important that you draw the right triangle in the correct place, otherwise you get things mixed up. This right triangle has to connect the origin, 0, 0, the point you plotted, and it has to be to the x-axis directly above or below it. It matters which quadrant you're in. So this does form a right triangle with the origin, point, and x-axis. Do not ever go to the y-axis. Part 3 says once you have this, label your known values, possibly even the unknowns that you're going to find. So you'll know your x value, your y value, those are known. But then maybe label the radius with r, and theta, which we're going to call the angle that's formed with the x-axis at the origin. You can label that as well, so that we know what we need to find. You need to find, remember, polar coordinates are made up of r and an angle, or a radius and an angle. Once you have that, you can now look down below, find the 4 different combinations. So step 4 says, hey, let's find that radius. And to find that radius, we use Pythagorean theorem. I already got it solved for r, square root of a squared plus b squared, the x and y coordinates. And then 5 is to find theta. And you can find theta that's formed. Now put x-axis and origin here. Add the origin so that you guys can understand where it's at. It's always at the origin, but it's also at the x-axis. Using inverse tangent. Because you're given a point that has x and y in it, essentially the I hat and j hat, you will always have an opposite and adjacent side. Which means if I use the inverse tangent, which has opposite and adjacent as part of it, you can find theta. There will be times where you're going to find the radius and it comes out to a nice number. When it comes out to a nice number, go ahead, use it, find the inverse cosine, inverse sine. Don't care. But the tangent, inverse tangent will always work. So that's why I added it as one of my steps. And once you have a radius and you have an angle, you can start to form the 4 different possibilities which are listed there. So the first thing we're going to want to do is convert negative 3i hat and plus 2j hat to polar form. So we're going to go through that list. The first thing on the list said, plot the point. Okay, so let's plot the point. 1, 2, 3 back, and 1, 2 up. Yes? I think necessarily, if I asked you to plot the point, that's all you see. But I'm going to use that point and this information of how far it took to get there to create a right triangle. This right triangle is formed between what? The point, the origin, and the x-axis that's directly below or above it. And that will form a right triangle. And here's the cool thing. It says label that triangle. Well, first of all, how far back did you go? How far up did you go? You know 2 of the sides of your triangle. And if I wanted to, which I think might be a good idea, you say, hey, wait a minute, we know r is that radius, or the hypotenuse, to get to that point, yes? And we know that eventually I'm going to have to find an angle at the origin and the x-axis there. I'm going to call that theta. It's a theta. It's a little hard to see on the screen there. Those two things, if I find those two things, I got it locked down. I can find the 4 different versions of polar form. I told you, I think it was in step 5, to find the radius, all I have to do is use Pythagorean's theorem. That says r squared is equal to 2 squared plus negative 3 squared. Or r squared equals to 4 plus 9, which is 13. Yeah? Or square root. So r is the square root of 13. Here's the thing. Square root of 13 is not a nice number. So should I put it as a decimal? Nah, probably not. Especially if the numbers are nice. Now, if my 2 and negative 3 there, or negative 3, 2, were not nice numbers, maybe putting it to a decimal might be okay. Now, there's something you should know. If I didn't have a calculator, I know that the square root of 13 is between which values?
7. Just kidding.
Square root of 13 is between 3 and 4. Because the perfect squares that it's most likely closest to is 16 and 9. And the square roots of 9 and 16 are 3 and 4. So it's somewhere between 3 and 4, and 13 is pretty close down the middle. So you would have to think that it's pretty close to 3.5 if you were to go to a decimal, which we're not going to. It is not nice. So I found r. That's cool. Let's write that in. Square root of 13. Let's write it there so we can have it. Again, mine's getting a little messy because I'm crossing my lines. You guys hopefully have a little more room. Then I have to find theta. Well, if I'm sitting at theta's perspective, 2 is what? It's the opposite. Negative 3 is the adjacent. And which one of the 3 of SOHCAHTOA have opposite and adjacent? Tangent. So that means that the tangent of theta is equal to 2 over negative 3. Would you guys agree with that?
Yes.
No, wait a minute. To solve for theta, I have to do what? Take the inverse tangent of both sides. I saw too much of this inverse tangent, cosine, and sines at the end. Never put it at the end. Put it in front. Squeeze it in there. Because I don't want to see it at the end. It's a function of that ratio. So therefore, I do not want to do a coefficient on the inverse tangent. Okay, that means something completely different. We should know that the inverse tangent and the tangent will cancel. You're left with theta equaling the inverse tangent of 2 over through negative 3. If you put that on your calculator, make sure you're in degrees, you get what? Everybody should be taking their calculators out at this point. I get a negative 33.69, or we'll just say 33.7. Wait. Negative 33.7? But that angle is supposed to be inside a triangle. Do we ever have negative angles inside a triangle? No. So, could I just take the absolute value of that and say it's just the 33.7? Yes. Now, let's take a look at what we did here. We formed a triangle. The reason that 3 is negative is because I walked backwards before I went up, right? But if I was going to really talk about a true triangle, can I have a side length that's negative? No. So technically, what happens when I take that negative off and say, hey, theta is equal to the inverse tangent of 2/3? Try 2/3 instead of negative 2/3. You should end up with a positive 33.7. Because I take that negative out, I am talking about the theta that's in a triangle that we don't necessarily have negative sides on. So therefore, it's a 33.7. I want to be positive angle. Now, how can that be 33.7? In that particular triangle, it makes sense. But if I wanted to get to that spot from the positive x-axis to here, that's not 33.7. That 33.7, ladies and gentlemen, is what we call a reference angle. It's the angle to get there in that particular triangle, and therefore we're going to use it by adding it or subtracting it from 180 and 360 so that we can get all of our angles. We now have all of the pieces we need. We know a theta, that's 33.7, which we'll use to our advantage, and we know the radius is the square root of 13. We now have the ability to create our 4 different points to get there. We should know 2 of them are going to be positive square root of 13, and 2 of them are going to be negative square root of 13s. Right? So, I will fill in the positive and negative angles as I find them. But, let's start with that first green line. I'm starting on the positive x-axis and going to the point where I stop when I hit that line. That's a positive direction. How far did I go? And how do I figure out that angle? What do you know theta is? It's 33.7. I kind of squeezed it down on my drawing there. But if I wanted to go all the way to the x-axis again, how far would that be? If I went all the way around? It'd be 180. But I'm not going 180. I'm going 33.7 degrees back from there. So what should I do? 180 minus 33.7. And you get what as an answer? 146.3. If I went 146 degrees, I would follow the big arc to there. Here's the thing, guys. Let's think of this circle as having to travel around it. If you know that your buddy is going one way and you're going to go the other way, and your buddy has already traveled 146.3 degrees of the circle, how much further do you have to go on the opposite direction to meet up with him? Yes, it's 360 degrees minus the 146.3. It's the other half of the circle. And a circle is 360 degrees. So therefore, what do you get? 213.7. Wait a minute. Wait. This is true. It's true that it's 213 degrees the other way, but the other way was in which direction? Negative. It was down or negative. So it's a negative 213.7. That should make sense because you should have a positive and you should have a positive negative. We now have a negative positive and a negative negative. No, it doesn't matter the order. You don't have to do things in a particular way. Now, we also hopefully realize that I could walk backwards at any given point as well. But to get to that point, I need to have my gaze in that direction. I need to be gazing in this direction and walking backwards. So now I'm looking down the dotted line, but I'm going to walk backwards. That's why we have a negative square root of 13 for both of those. The easiest way to get to that dotted line is to just turn backwards just a little bit. How much is that little bit? It's 33.7. But since I'm going backwards, it's negative 33.7. And how do we know this? Because it's a vertical angle to theta, right? These are vertical angles. Vertical angles are congruent to the same. We know that the other half of that angle, or part of that angle, is 33.7. So that since they're vertical angles, they're the same. And again, this whole idea that if your friend went 33.7 degrees down or to the left or to the right, and you want to go to the left, okay, so going clockwise, how far would you have to go to meet up with him if you decided to go all the way the long way? 360 minus the 33.7, which is 326.3. Here's the next point. It's 4 I hat and minus 3 j hat. So, again, number one rule, plot the point. 1, 2, 3, 4, 1, 2, 3. And form the triangle. Should I go up or left? Up, because it should be to the x-axis. You know, guys, that this is 3 or 4, and that is, it's a negative 3 because I'm going down. But when I form my triangle or use my triangle, I can turn that to a positive 4. Now, this is the thing. On your ACT, in certain types of questions, they throw in right triangles that are special. This makes things go a little bit quicker for us. This is a special right triangle because it's a 3, 4, 5 triangle. It's used quite a bit in the ACT. So 4 squared is 16, 9 squared is 9, or 3 squared is 9, and 16 plus 9 is 25. Square root of 25 is 5. It's a 3, 4, 5 triangle. Theta, remember, is at the origin. It's the reason I chose this one, or these numbers. Now, 5's a nice number, right? So if I wanted to solve for theta, I'm not limited to just the inverse tangent, or tangent. Because 5's a nice number, I'll use sine or cosine. The thing is, if you want to keep things consistent, always use tangent. I'm going to use tangent. Tangent of theta is equal to what? 3 over 4. Notice that Vikai changed it to a 3 instead of a negative 3 because we're talking about a particular triangle. We can ignore the negative, which will lead us to hopefully a positive angle because that's what we want. To get rid of tangent, you will take the inverse tangent. Again, I want to see inverse tangent in front of the number or the ratio, not behind it. So theta equals, you should also be listing what it equals before you change it, because when you change it, you're changing it to an approximation more likely than not. So give me an exact answer before you go to an approximation. 36.8. Okay, so we get 36.8. We know R, we know theta, we now can start to put it together. If this is 36.8, I think I know which one's going to be the easiest one to find for me. What's the easiest angle to find? easiest angle is to go straight to it, right? How far is that? How far is that purple line? 36.8, but I went down, so it's negative. And if I turn a negative 36.8, am I going forwards or backwards? Forward. If I start on the x-axis and I travel straight down to this point, I walk forward. I then also can go all the way around to here, which is taking 360 and so it becomes what? 3, 3. 323.2. Anybody going to back that up? And that should be positive because I went in a positive counterclockwise rotation. Also recognize that I could be looking in this direction. And wait a minute, what would be this angle down here? What's that angle? 36.8. So, if I wanted to get to that point, what do I need to do? How many degrees? Someone other than Baikai. 180 minus 36.8. We all have our calculators out. Let's go. 143.2. This is not so bad then, right? And of course, if you're going to meet your friend there, taking the other direction, it's going to definitely be negative. It's 180. It's the 180 plus. What's it going to be? I don't think it's going to be 17.
70.
How about 180 plus 36 is what?
07. Oh no. What is it?
So it ends up being negative 216.8 to get there. It's an 8. Your homework then for tonight is to do the other half of the worksheet, the back side. So here we go. Homework is worksheet problems 5 through 8. Convert. Have a great day.